This video covers review 11, pages 2 through 5. Because we did page 1 in class on a different day, there is a different video also on this website to help you with page 1. So this is pages 2 through 5. So starting with problem 1 on page 2, we have a problem that has all numbers. So for this problem, you need to put this exactly like you see it into the calculator. We have 3 raised to the negative 3, and we get this ugly decimal. When you click Math, Enter, we get the fraction 1 over 27, and that is simply my answer. Problem 2 has the number 2, an A, a B, and a C value. So we're going to break it up one by one. When I look at the number 2, there's nothing else, no other big normal numbers to change this. So the number 2 is just going to say the number 2. When I look at A is to the 0 power. Well, anything to the 0 power means write this 0 times, so we don't need to write it. B is written B to the negative 4. The negative means it does not like where it is at, so B does not like being on the top, meaning we need to move it to the bottom. So this will become 1 over B to the 4. Remember, when you move something like from the top to the bottom, wherever it was negative, it is now positive on the opposite top or bottom. So it was negative on the top, but it is positive on the bottom. So B to the 4 is now written on the bottom. C is just C. C is fine where it is. It's a positive exponent, so it has no problems being where it is. There's no other exponents. There's no 0. There's nothing else to combine it with. Problem 3 is a multiplication problem, so we're going to take it big numbers first, and then our A's. If you rewrite it like this, you are a lot more likely to see success in the correct answer. So we wrote number times number, negative 4 times negative 5. I put that into my calculator, and I get 20. With my A's, I have A to the 4 times A to the 3. Because these are multiplied, I look at my formula chart, and it tells me to add. So I add 4 plus 3 to get 7. So I have 20A to the 7 total. Problem 4 is also a multiplication problem. Even though there's not a multiplication sign, I have parentheses, which tells me I need to multiply. I make sure outside of my parentheses that I don't have any extra powers, power to a power, and I don't, which means this is a strictly multiplication problem. So numbers first, 4 times 3 times negative 2, and we get negative 24. And then I have A times A cubed times A squared. Remember, if there's no exponent listed, it's really an invisible or imaginary 1. So I add all of these because they are separated through multiplication sign. So I have 1A and 3A's and 2A's for a total of 6A's. And then for the B's, we have B2 times B4. Again, these are separated through multiplication, so I really add the little numbers. So 2 plus 4 is 6. So put it all together, negative 24, A6, B6. Remember that your answers need to go number and then letters in alphabetical order. So numbers and then A, then B. Problem 5, we have a division problem. We don't have any parentheses, but I can see I have number, A, B, B. So I need to double check. I don't have any negative exponents, so I'm going to take it one piece at a time. So numbers first, and then letters. And with the letters, I'm going to take it letter by letter. So with my numbers, I have negative 15 over 18. I'm going to put that in the calculator. Negative 15 divided by 18. I plug it in exactly like I see it, in the same order I see it, and I get this ugly decimal. So I click Math, Enter, and I get negative 5 over 6. What that means is negative 15 divided by 18 does not reduce nicely into a nice number. Excuse me. So I'm going to have my fraction there. I'm going to use my fraction to start the rest of my fraction answer. Some of your fractions will end up with fractional answers. Some of them completely cancel. So don't get worried either way. Sometimes you still have a fraction, sometimes you don't. With my A's, I have a to the 4 over a to the 2, so I have 4 a's on top, which is more. So my answer needs to end back up on the top. When we divide, we really subtract our exponents. So 4 minus 2 is 2. And again, because I started with more a's on the top, they are going to finish on the top as well. With my b's, I have 6 on the bottom and only 3 on the top, so I have more on the bottom. So my answer needs to end up on the bottom. I take b to the 6 and subtract 3, so I get b3, and it needs to go on the bottom. So b cubed goes on the bottom of my fraction that I started. So when I have negative 5, 6, negative 5 is on the top, 6 is on the bottom. A goes on the top, so it goes up with 5. B is on the bottom, so it goes with 6. For problem 6, I have another fractional one. I do not have any parentheses that I need to worry about first. However, I do have a negative exponent and a 0, so I'm going to clean some stuff up really quickly. Anything to the 0 power is 1 or it cancels, so we can just cross it out. And I'm going to move this a down to the bottom so that it will be positive and I don't have to worry about dealing with a negative exponent. So a to the negative 5 is the same thing as 1 over a to the 5, so I move it to the bottom. Looking at my numbers, I have 20 divided by 4, which is 5. Looking at my a's, I have a to the 6th and a to the 5th, both on the bottom. Because they are both on the bottom or both in the same place, I'm going to multiply them, which really means I add. So 6 plus 5 is 11 a's total, and again, notice they are on the bottom. And then the b's, I have some on the top and some on the bottom. I have 6 on the top and 2 on the bottom. 6 on the top is bigger than 2 on the bottom, so my answer needs to end back up on the top. 6 minus 2 is 4, and again, this goes on the top. So 5 goes on the top, a to the 11 goes on the bottom, and b to the 4 goes on top. Again, remember, if you write your a's like this because they started on the bottom, it will help you remember that they need to end up on the bottom. Problem 7, I have a fraction or dividing. I also have parentheses on the top, so I'm going to deal with the top first and simply rewrite the bottom because I'm not going to change anything about that yet. On the top, I multiply my numbers. 6 times 4 is 24. And then a to the 2 and a to the 6, we add to get a to the 8. From here, I divide number by number and then letter by letter. So 24 divided by 3 is 8. A to the 8 has more on the top. I subtract because it's a division problem. 8 minus 7 is 1. So 8 is normal. A is on the top. So this is an example where we started with a fraction but did not end up with a fraction for our answer. And that's okay because sometimes you have a lot more on the top and everything is bigger on the top, so it will all work itself out. Problem 8, people are seeing success by writing what's in parentheses this many times and then treating it like a normal multiplication problem. So 4b to the 5 is written out 3 times because that's the exponent we have on the outside. So we write it this many times. From here, I treat it like a multiplication problem like we did on problem 4. Multiply my big numbers, 4 times 4 times 4. And then b to the 5, b to the 5, b to the 5. 4 times 4 times 4 is 64. B to the 5 plus 5 plus 5 is 15. So we have 64b to the 15. Now you can distribute your powers and do 4 cubed b to the 5th cubed, where you multiply these and you put this number in your calculator. Be very careful that you do not do 4 times 3. It is 4 cubed, so 4 times itself 3 times. But that is your power to a power quick rule. Problem 9, I'm going to write this out this many times, so 3a squared 3 times. And then 4b to the 2, I'm going to write out 0 times, meaning I'm not going to write it at all. It's basically as if that part was not there. The whole thing is not 0, so I can't cancel the whole thing, but I can just write this 3 times and not do anything with the other part. Normal multiplication, 3 times 3 times 3 is 27. A squared times A squared times A squared. I add, I have 2 plus 2 plus 2 for a total of 6 A's. Again, your product rule is 3 cubed A squared cubed. 2 times 3 is 6. 3 cubed is 27. So either way you do it, you should be getting the right answers. Problem 10 is another multiplication problem, so 3 times 7, number times number is 21. A to the 1/3 times A to the 4/3. I add these for a total of 5/3. Make sure you're using your calculator with those fractions because I have some people who are not adding correctly. B to the 1/4 times 3/2 is 1/4 plus 3/2, math, inner, 7/4. So we get 21, A to the 5/3, B to the 7/4. Problem 11, I have a product rule, so I'm going to write this many times. 6A to the 1/4, 6A to the 1/4, and then I'm going to write this many times. And now it becomes a normal multiplication problem. 6 times 6 is 36. And then I have A to the 1/4 plus 1/4 plus 1/2 plus 1/2 plus 1/2 plus 1/2. So I add all these together. Math, inner, and I get 5/2. So this is A to the 5/2. So I have 36 A to the 5/2. Problem 12 is a division problem. Anytime you see those fractions, if you can't tell me which one's bigger on top or the bottom, make sure you convert those fractions into decimals. So 4/3 as a decimal, we can just do 4 divided by 3, and we get 1.3. We can see that 2 is bigger than 3. So I'm going to subtract 2 minus 4/3, and I'm going to put it on the top because that's where I have more. When I subtract those, I get 2/3. With my b's, 3/2 is the same thing as 1.5. So 4 is bigger than 1.5. And so I subtract. Math, inner, and I get 5/2. This one also goes on the top because it was bigger on the top. So A to the 2/3 goes on top, and B to the 5/2 goes on top. Don't let those fractions trip you up. Treat them like normal things. Problem 13, they're telling us the area is 12A7B4 and the width is 4A squared B2, and they are asking us for the length. So remember, our area formula is length times width. We are given the area and we're asked to find the length, meaning we need to divide. So I'm going to take my area and divide it by my width. When I divide, I treat big numbers like normal. So 12 divided by 4 is 3. A to the 7 over a squared. I have 7 on top, so I have more on top. I subtract 7 minus 2 is 5. And then for my b's, I have 4 on top, 2 on the bottom. There's more on top. So 4 minus 2 is 2, and they all stay on top. So 3A, 5B, 2, all exactly where it was, are on the top. On problem 14, they're telling us the height is 6a squared b5 and the base is 4a cubed b4, and they're asking us to find the area. So if you're asked to find the area, it means you're going to need to multiply, and if you're given the area like we were right above, then we need to divide. When we multiply, we treat big numbers like normal. 6 times 4 is 24. With our a's, a squared times a cubed, we add 5. And then b5 times b4, we add to get 9. So I have 24, a5, b9. Problem 15 is asking us to find the area of a square who has a side of a5, b2. Remember that with this square, both of your sides are exactly the same, and we're reminded right here that area is length times width. So we can simply do a5b2 times a5b2 or square it. So a to the 5 plus 5 is 10. B to the 2 plus 2 is 4. So I have a10, b4. Problem 16, we have a length, a width, and a height, and they ask us to find the volume. When you're asked to find the volume, you're going to multiply all three of these. So we have c squared d times cd4 times c3d5. Again, when I multiply, go letter by letter. So c squared, c, and c cubed, imaginary 1, so a total of 6, d, d4, d5, imaginary 1, so total of 10. So C6, D10 would be the volume of my prism. 17 asks which of the following is written in simplest form, explain. So F, we have a number that has an exponent, meaning we could put this into the calculator. On H, we have something that can be canceled. On G, we have parentheses that we would need to distribute. On J, we have letter, 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 and nothing is repeated. So my explanation would be J, because nothing can be simplified. Again, on F, 3 to the 5th, we can simplify in the calculator. Anything to the 0 can be simplified. Anytime you have parentheses, you're definitely not simplified. So J is my most simplified answer because there's nothing else I can do or need to do. These problems are review. So 18 asks us for the domain of the function. Domain, if you remember Dr. XY, domain is your x values. So we put x in the middle. And we have this little piece right here to remind us what we need to do. My x's go from left to right. So from the left over here, my x value is at a -9. At -9, we have a closed-in circle, so we put the line under the inequality. And then on the far right, my domain stretches, or my x's stretch all the way out to 7. At 7, we have a closed bubble, so that also gets a line, a closed-in or filled-in line. And then my range is my y values. Y's go from the bottom to the top. So they're showing us here, that'd be the blue, bottom to top. So on the bottom, I'm all the way down at -6. There is a value at -6, so I put a line under the inequality. And this goes all the way up to 4. Note that I'm not using the bubbles necessarily. I'm using the lowest point and the highest point. My domain happened to be bubbles. Your range can be bubbles, but it needs to be the lowest point and the highest point, so it's not always the bubbles that are on the graph. Problem 20 gives us a graph and asks us to list the ordered pair that represents the x-intercept. So remember, the x-intercept means we have a 0 for y. We have a value at 0, so a number at 0, and a nothing for y, or a 0 for y. So the x-intercept where it crosses the x-axis is here at 4, so that is the point 4, 0. The ordered pair for the y-intercept means we have a 0 for x and a number at y. It is the point where we cross the y-axis, which is the point 2. So 0, 2 as the point. 22 tells us the formula for potential energy is P equals mgh, where P is potential, m is mass, g is gravity, and h is height. Write an equation to represent g. What that means is get g by itself. So G has a couple things on the same side. It has M and H. M and H do not have any operations shown, which means it's really multiplication. To get rid of multiplication, we divide. Whatever we do on the right side, we have to do on the left side as well, or one side has to be on the other. My M's cancel on the right side, and I'm left with G. On the left side, I do not have any like terms, so I simply rewrite P divided by M and H. And that's all I have to do. Last page. 23 asks me to solve and then graph. I need to solve for y before I can graph, so I move 4x to the other side. Whatever I do to one side, I do to the other. My inequality symbol was a less than sign, and I've done nothing to change that. To graph, I start up at 2 and go down 4, right 1. Down 4, right 1. This line will be solid, and that is reminded of us right here on this graphic. So I draw a solid line through those dots. And then y is less than or equal to 2. Less than 2 would be underneath. And again, this graphic is showing us anytime you have a less than, you're going to go underneath the line. Now you need to know, this graphic is just kind of helping you remember things. As long as you remember what you're doing, the graphic will be helpful. If you don't know what you're doing, it's not going to help you that much, honestly. Problem 24 asks us to find the solution, so we need to solve for x. I first need to distribute 3 times x, which is 3x, and 3 times negative 1, which is negative 3. I also need to distribute 1/5. 1/5 times 30 is 6. 1/5 times 5x is x. I am now going to combine my like terms. X plus 3x is a total of 4x. Now I will move my x's to the same side. I have boxes on opposite sides of the equal sign, so I need to move it through the opposite operation. So 4x minus 1x is 3x. Everything else stays the same. In order to solve for x, I add 3 to both sides. So 3x equals 9. And finish by dividing both sides by 3. X equals 3. Problem 25 asks us to find the range of f of x equals negative 2x squared minus 3, given that the domain is 2, negative 3, and 4. So what we can do is put this equation, negative 2x squared minus 3, into y equals on the calculator. And then look at our table to find those values. So we can write them out. 2, negative 3, and 4, and the table is going to give us those y values. So in y equals, I type negative 2x squared plus 3, minus 3, and click second graph to go to my table. For my table, I need to know when x is 2, what is y? When x is 2, y is negative 11. When x is negative 3, y is negative 21. And when x is 4, y is negative 35. So my range is negative 11, negative 21, and negative 35. Problem 26 asks me to find the rate of change for the line with the equation 3x plus 2y equals 10. In order to solve this, I need to solve for y so I can find my rate of change. I move x to the other side through the opposite operation. I bring 2y down. 10 and negative 3x are not like terms, so I simply rewrite. And then to finish solving for y, I divide every piece by 2. So y equals negative 3/2 x plus 5. The question asks me for the rate of change, which is your m value. In the equation y equals mx plus b, we can see m is always with x. So our m value is negative 3/2. The last problem gives us a system of equations and asks us to write our two equations but not solve. So 27 says the Lakers scored a total of 80 points in a basketball game against the Bulls. The Lakers made a total of 37 2-point and 3-point baskets. How many 2-point shots did they make? Let x be 2-point and y be 3-point. So x is 2-point and y is 3-point. So for this setup, we're going to have a baskets equation and then a points equation. So baskets, I know that there are 37 baskets total. So I had some 2-point baskets and some 3-point baskets for a total of 37 baskets. And then points, I know there's 2-point baskets and 3-point baskets, so 2-point baskets, 3-point baskets for a total of 80 points. So points plus points equals points.